This example illustrates that it's not always just as simple as replacing the allylic hydrogen with a bromine. Because we're dealing with resonance structures, we really need to consider all the resonance structures that can lead to different products. So what you want to do, if given a problem like this, here we have the double bond with NBS. Start by drawing your radical intermediate, and that's going to come from abstracting the allylic hydrogen. If you have more than one allylic hydrogen, you may need to draw a couple of possibilities there as well. So in this case, if I abstract that allylic hydrogen, I get this radical. And this has a resonance structure. Here's the other resonance structure. These two represent a single intermediate that is the resonance hybrid. From there, each of these resonance structures, you can think about them reacting with Br2 to give a different product. So I'll draw my arrows in for this step. And then draw our products. So now what you want to do is analyze both of these products. This is product A and product B. And we've learned about double bond stability. So the one that gives the more substituted double bond is more stable and is going to be a favored product. So product A has a mono-substituted double bond. Product B has a tri-substituted double bond. It's more stable. Because of that, it's the major product. You can look at this on a reaction diagram. Let me also label our starting material. If we were to draw a reaction diagram for this, here's our energy, reaction progress. We're going from our starting material, and that will go over a transition state to get to the intermediate. So maybe I'll put the intermediate right here. Remember, we don't actually have two different intermediates. These are both represented by a single intermediate, the resonance hybrid. But the character at each position can lead to the two different products. From the intermediate, then we can go to product A or product B. And product B is lower in energy. So now as you go over the next transition state to get to the product, product B is going to be lower in energy, so that is more favored. If you look at the difference here, here's the delta H. Starting material to product B is a more negative delta H. It's more favored.